focusly on the RF filter design. Okay, today we will focus on m-Derived filter sections. Where are we? Okay, start sharing, start broadcast. Okay, here we are the second method on the image parameter method, which is m-Derived filter section. The same as K, constant K, so it has the T form, pi form for low pass and high pass filter. So let's go through. So m-Derived filter section. The m-Derived filter is a modification of the constant K filter design to overcome the problem of slow rate of attenuation and the change of image impedance. So that's why m-Derived filter section is introduced. So if you can see the problem of constant K attenuation, so basically it's a problem of two problems. One is the cutoff is not sharp, and second one, the impedance, the image impedance is keep on changing based on the frequency. So to solve the problem, we introduce this m-Derived attenuation. So m-Derived attenuation has a sharp cutoff, but again, after the certain cutoff frequency, okay, after certain omega here, so the attenuation is reduced significantly. In order to maintain the attenuation, maybe so we will try to introduce the third method, which is to have a composite response as a way to maintain the attenuation. So we will discuss later on. Here we only focus on the m-Derived low pass filter. So the same as the constant K filter design, so it also have the T form and pi form. But here, so I will just focus or put it here in the T form for the low pass and high pass filter using the T form only. Okay, for the low pass filter here, so it use the parallel, which have the both inductor and capacitor, and all of them has the sum value of m here. So that's why all is using, we call it as a m-Derived filter section. So when we want to have almost for the matching, so we choose m equivalent to 0.6, while to have a sharp cutoff, we will choose a square root of 1 minus omega c over omega infinity to the power of 2. Again, if L is given, L and C is given, so we can find R0 and omega C. And if R0 and omega C is given, so we can find L and C. Okay. Vice versa to that low pass filter, we have the high pass filter. Okay, all the position of inductor and capacitor in low pass filter have been changed to capacitor, and also inductor change to capacitor, capacitor change to inductor. So this the value is still the same, and the value for LC is same for the constant K section. When we put the value of M, okay, whether in, for example, here in the pi network, okay, never mind, I think the T or pi network is almost the same. So we can see here, so when M equivalent to 0.6, it almost near to R0. So that's why M equivalent to 0.6 is chosen for a matching. And if we choose m or less than 0.6, so the value of R0 will Z pi, which is will be less than R0. And if we choose m more than 0.6, it will increase more than R0. Okay. So this is how m is chosen. Let's see the example here. So first example here, low pass m-Derived section introduce an infinite attenuation pole at 2.05 MHz, while the cutoff frequency is at 2 MHz. Find the value of m. So here how we want to find the value of m. Okay. So we use this formula, m equivalent to square root of 1 minus omega c divided by omega infinity to the power of 2. So since omega is 2 pi f, so we can replace omega c to fc and omega infinity to f infinity. So we just include the value of the frequency, and finally I think from this the answer will be 0.21 if I'm not mistaken. Anyway, you can calculate by yourself. Oh, I think maybe 0.6. Okay, so you need to calculate by yourself. So next, the answer is there. Low pass m-Derived section with m equivalent to 0.197, L equivalent to 3.18 Henry, and C equivalent to 127 nanofarad. Find the value of inductor in shunt arm. So you need to draw back the low pass filter m-Derived section. So you have the both arm inductor value, but okay. And in the middle here, so the question asks to find the value of the shunt arm. So here, so you need to use the 1 minus m to the power of 2 times divided by 4m times L. So you just include the value, and I think the answer will be, what is it? I'm also not sure. So we'll discuss in the class. So maybe the answer is A. So you need to calculate. Next. Next, a high pass m-Derived pi section. So although the example given in this video is in T section, here the question asks about the pi section with m equivalent to 0.28 and C equivalent to 21.22 nanofarad. Find the value of capacitor in the circuit. So now you need to know about the design of high pass filter using the pi section. You need to draw the circuit. So the circuit is given here. Okay, so actually you just change the capacitor in the T section. You separate it into two parts to make this an inductor, while you combine the inductor and capacitor at the top of the circuit. Okay, so C and M is given, so you just include this formula and you can calculate the value. I'm also not sure, so you can calculate it. I think maybe C or D, so we can discuss it later in the class. Okay, that's all for this session, and I hope you enjoyed this video. Thank you.